All right. Hello, everyone. Hello, and welcome to another episode of BIM After Dark Live. My name is Jeff, also known as the Revit Kid. This is episode 93, and I'm. Oh, there we go. Anthony and I were having a good conversation off camera, so I was trying to get everything going there. So this is episode 93, and we're going to be talking about computers and hardware. I'm sure everyone out there at some point in time, if not this year, the year before, or coming up this year, you're sitting there looking at i9, i7, i5, 9600 megahertz, 5.3 gigahertz, 4070s, 40. You go through the list, right? We've all been there, and we're trying to figure out what is the best hardware for what we do. And as architects and engineers, and contractors and BIM managers, we have a unique requirement for hardware between Revit, Navisworks, AutoCAD, Twinmotion, Lumion, Enscape. You go down the list, they all require a unique hardware solution that's always kind of hard to find with your out-of-the-box system. So the goal today is to make you smarter, and that's the plan. And so we're going to bring in a guest who is going to help us make you smarter. And with that, I will introduce you guys to Anthony Remis. Anthony, how's it going?
Hi, Jeff. Thanks for having me on, man. My name's Anthony Remis, and I own and operate Remis Computer Solutions out of Vegas. And since 2015, I've been building pretty awesome workstations. Accidentally niching into, the AEC space, but I'm so happy it worked out that way.
Definitely. Yeah, the AAC space is unique in itself. And so anytime I can find someone who knows what we do, and then also knows the geeky computer side of it, I think is always helpful. And so it's hard to find that, and I'm sure everyone out there watching this is running into the same thing. You're not gonna walk into your local Microsoft store or call up your local Dell rep, and they're gonna know what the hell you're talking about when you say, "Well, I need something that runs Revit and Lumion." and so and
Yeah,
so uh,
yeah.
so it's always great to have someone who doesn't just know hardware but understands at least what kind of software we're trying to run through it. So maybe just a little background on yourself. So you build custom PCs, but how did you get to this point?
So really, that was computers was something I was always interested in, whether it was in high school in the 90s, or even as an enthusiast, while having a professional job. I actually was a Mercedes-Benz technician, so I was, turning wrenches on cars that really basically were computers on wheels. Um, and then I transitioned through different careers through, when the economy crashed, but ultimately out of a passion of my hobby of computers is how I started my business to build computers. Uh, I got into Revit because my very first business client, an awesome architecture firm in Costa Mesa, was looking for a local person to build them computers. They got burned by their LA guy,
Hmm.
and I had no idea what Revit needed. So I let him know, like, hey, let me research this. I found Revit for him online. They had so many good, useful bits of information there. And actually, because they were local, I was in Huntington Beach at the time. I was able to shadow them and run some data logging software and actually see what Revit was doing in order to make a recommendation for them. They're a firm that does VR. They do everything. All of their clients now get VR headsets whenever they
Hmm.
start a project with them. But
Yeah.
um, so I really got to learn so much from them just because they were down the street essentially, and I'm now able to apply that to all of my clients.
Awesome. No, that's great. And yeah, I mean, obviously, Revit is probably the main tool of choice by most of the audience here. But it
Yeah.
is, as you went through that process, then, you know, and starting to understand the lovely back end of what's happening on Revit, and
Yeah,
then and
yeah.
then and then when they start throwing in programs like whether it's Enscape or Lumion or Twinmotion or something that they're using for the VR goggles, how does that dynamic as someone who understands the computer side, but now is just kind of seeing these programs on the outside, that what bells did that ring in your mind when you're talking about building a machine that can handle this stuff?
Well, you definitely need a capable CPU for Revit, and that also needs to feed the video card as well. You don't want to create any bottlenecks. But when you're in Enscape or Lumion or whatnot, some of the biggest shocks I had were watching last generation's top tier video card struggle with the projects they're doing. And they're just doing estates. They're not even doing,
Hmm.
you know, massive commercial projects. So literally watching a video card choke that was top end like last generation, um, really you just can't underestimate the necessity for good hardware.
Hmm. So with that in mind, then I guess before we start jumping into the ins and outs of the hardware, um, you know, this stuff moves fast, as I'm sure we're all aware of, right? And even before we hopped on, we were talking about how crazy the benchmarking between even just a GPU that's only less than 2 years old versus today, how crazy different the benchmarking is on those. If I'm running an architecture firm and I'm trying to plan out how often I'm going to upgrade, for example,
Right.
is like new every two even going to work, or you're talking new every year at this point in time, just because of the acceleration you're seeing in the software?
I think there would be certain power users that may benefit from like a 2 year life cycle. Um, I think in a perfect world, 3 to 4 years. Unfortunately, there are firms that are trying to get 5 years out of their systems.
Hmm.
And so it really depends. If you're trying to get systems every 2 to 3 years, you can maybe get the i7. But if you're trying to get a 5 year life cycle out of a system, you basically need the i9 just to get you through those tail end years. Um, but there's like a sweet spot, and then there's where like you get the i7, for example, and then you get the icing on the cake with the i9. I hate to say like you need an i9 or you need an i7 because every firm is different. Um, so that's what I try to actually educate. Um, what is it that you're doing? Are you doing, remodels? Are you doing, commercial projects? It really depends on what they're doing.
Hmm. So let's jump right into it then, because I think as far as working through the components, I'm guessing processor's probably the best place to start, because that kind of sets up the system in general. Um,
Yeah.
Motherboard slash processor, but we'll say processor for the sake of tonight. And so you obviously are mentioning i7, i9. For people who don't know what you're talking about when you say that, maybe there's people out there who don't even understand what that means, which is fine. Maybe give them an idea of what you mean by by i7, i9.
Sure. I think what's important to know is that AMD does have a good product. But at the moment, and I did sell a lot of AMD workstations not that long ago when Intel was in their 11th gen era. But we'll stick with Intel because that's what I'm recommending, and they're really the best for Revit at this point and other BIM applications.
Hmm.
They structure their CPUs. You got i3, i5, i7, i9. i9's being your highest end, and then i7 would be high end, but less cores,
Hmm.
less frequency, and it basically goes that way as you go with the i5s and i3s. Um, when shopping for a BIM system, the applications like Revit it's not single threaded all the time.
Hmm.
There's mixed workloads, and that's one thing you have to understand when understanding, oh, this CPU says 6 gigahertz. This one says 5.5. Um, Intel's using dynamic clock speeds, meaning you'll get 6 gigahertz if you're only using 2 cores or less.
Hmm.
And then it'll switch to, 5.6 gigahertz for anything more than 3 cores or more.
Hmm.
Um, the other thing too is depending on the motherboard or the manufacturer, you may only get your top performance for an envelope of 30 seconds before it'll downgrade your speeds. So going with boutique builders, we're using higher end boards that can lock the CPU at their max speeds indefinitely. So a CPU isn't just a CPU, it really comes down to the cooling solution. So while like currently the 13700K i7, the 13900K i9, those are my two favorite CPUs for Revit. Um, you may see them in a system that may cost $1,000 less than someone else's,
Mhm.
and you may think, oh, there's no difference. They have the same CPU. Now, because of these dynamic clock speeds, you actually have to pay attention to the cooling
Mm.
because otherwise you'll never get the full potential out of your CPU because Intel won't consider it overheating until it's like over 100 degrees Celsius. Nobody's technically lying about the performance they're delivering. Both manufacturers can say we're delivering Intel's certified performance, but the experience can be completely different.
Mhm. So
So,
if I'm choosing a processor, and let's, for the sake of argument, let's say that we're choosing from a drop down on a manufacturer. Maybe our company told us we have to use HP or Dell or something like that, right? And so now you're going to the website, and now you've got four options of processors, right? What, as Revit users, let's say, with obviously other stuff happening as well, what are we immediately just dropping down, if we can afford it, immediately just dropping down to the highest price, highest whatever, or looking through the statistics or numbers or specs of each one. How would you go about that, or how can you help us lay people choose the best one, while also understanding that maybe we don't have the budget to jump right to the highest level i9 and drop 1,400 bucks just on the processor, right?
yeah, so if the budget allows, by all means, get the best CPU you can afford, which
Mhm,
would be the i9.
mhm,
Um, if budget is limited to a certain amount, I'm probably gonna upset some people, but a 13600K i5 is gonna deliver like 85% of the performance in Revit that the i7 and i9 will deliver.
mhm,
This 13th gen Intel like ecosystem is so good. Like I was running the RFO benchmarks on all of these CPUs, and they're really within just single digits
mhm,
seconds of each other, you
mhm,
know. So I've actually built a few i5 Revit systems,
mhm,
but when you're going through the Dell dropdown or the HP dropdown, once you get into the i5, that actually just means value to them, budget to them. So you really want to stay in the i7,
mhm,
do everything you can to at least get an i7. That will give you a good balance of cores and frequency.
mhm,
Um, and ultimately, the i7 and the i9 both have the same amount of performance cores. It's just the i9 gives you more efficient cores, which you're not really using for Revit. It'd
mhm,
be more for like a rendering task.
mhm. So
Um,
so that but that's a great point. So if your core usage is Revit, that's one thing. But then you have to think about, okay, I need the best processor for Revit, but hold on, I'm also using Twinmotion every day. So now, how does that change your thinking on even just processor selection? Immediately, people, and I would do it too. When you think of that, you're like, I'm thinking immediately graphics card. But what you just said there is important, because it's not just graphics card for Enscape or Lumion or Twinmotion, right? It's more than that.
yeah, it really just depends on the software suite you're using. So the visualization users, you're going to want to give them not only the best video card you can afford, but the CPU is going to matter as well.
Mm-hmm.
Um, it depends on what type of rendering, what type of animations, what kind of walkthroughs they're trying to do, VR especially. Frequency also starts to play an important role too. For example, a 4090 video card could get bottlenecked by an i7.
Mm-hmm.
Um, so ultimately, it's all about budget. So if I had to pick an i7 in order to pick a better video card for like a Twinmotion user,
Mm-hmm.
I would rather make that sacrifice because if someone's living in Twinmotion, Enscape, Lumion,
Mm-hmm.
I would at least want a 3080. Um, by today's generation, really 4070 Ti would be amazing, but VRAM wise, I would say at least a 4080 today. So a computer is all about balance. It's hard to just say just get an i7 and you'll be golden. I'm like, well, if that i7 or if that i9 is gonna if you get the i9, but now you have to have an RTX 3060 and you're trying to work in Twinmotion,
Hmm.
the system's not balanced.
Mm.
I'd rather do the i7 and then go like a 3080, 3090, 4080.
Hmm.
Um, I always try to preach balance.
Hmm.
Um, so that's
So
a
before
consideration.
before we move on a little bit, there was a couple questions about Ryzen and AMD kind of stuff. So I know you mentioned you know, your suggestion is Intel. Got it. Is there, you know, is that more of a preference, or or is that something that you found via, you know, benchmarking and specs, that you're just finding better results or more consistent results or just more efficient results, whatever it is with the Intel chips?
Yeah, so every generation that comes out, I buy the CPUs. I'm not cool enough to get free stuff from the manufacturers yet. So I have a 7900X system behind me that I used as my test bench.
Hmm.
It was much slower in the RFO benchmark.
Hmm.
It shouldn't have been
Based on
because,
specifications alone, speed and whatnot.
well, in very parallel benchmarks, like Cinebench is a awesome tool I like to benchmark in just to get quick baselines.
Hmm.
The 7900X single core performance was through the roof.
Hmm.
It was basically on par with the 13900K.
Hmm.
But then when you plug it into Revit, like in the RFO benchmark, it was like 10 seconds slower.
Hmm.
So, I mean, it's still great. It's still,
Right.
a 68-second run. But when the i9's like 55 seconds,
Hmm.
that really comes down to the latency that's inside of the CPU.
Hmm.
Um, AMD got, I think AMD realized this and they're releasing their high cache CPUs, their Core 3DX models now.
Hmm.
So that will now require more benchmarking.
Hmm.
But the 7900X versus the i7 was still getting beat, and those are their two
Hmm.
closest competitors.
Hmm.
Because AEC and BIM applications are latency sensitive,
Got it.
Intel's just king right there.
Hmm. So it's not just 3.8 gigahertz. It's the latency of the chip itself.
Yeah,
Yeah.
it gets into some, you know, it gets really nerdy getting into this part of it, but
Hmm.
just know Intel's basically best for your BIM applications at this moment.
Hmm.
Um, and AMD would still deliver a great experience,
Hmm.
but if you're going to spend the same amount of money, you might as well get the better system.
Got it. That makes sense. No, it completely makes sense. So along the lines of balance, I think before we jump into graphics cards, one thing I'm always interested in is RAM. And when I think of balance, you know, and I think of RAM, you know, the one thing that we always struggle with building these monster BIM machines is, you know, we can start putting a lot of RAM in these things, right? And
Yeah.
and at what point in time is it like just we're just spending money that we're not using, right? And that's so like
Yeah.
64 seems to be almost the baseline now, but like it are we if we put 128 in a desktop, are we using it? Like am I using it? Do I need it? Is it there, or is 64 right now like we're not even using a majority of that?
Yeah, RAM, you got to be really careful overspending,
Mhm.
overbuying.
Right.
You're only using what you need.
Mhm.
Having RAM sit around does nothing for you performance wise. And it comes down to your desk.
Mhm.
If you have a huge desk, let's say your desk is 10 feet wide and 8 feet deep, you could stack all your papers there. You got a bunch of empty space, but at least you could organize. If you have a tiny desk and you got to start putting papers on the floor, it's going to be slower for you to access your papers. That would be a situation of not enough RAM. So your information is now going to the hard drive rather than staying in your RAM.
Mhm.
When you have the right size desk, you're not slow. You're not being slowed down at all. It's not costing you performance. Having too much RAM, you just have wasted space essentially. It's wasted money because once you start configuring 128 gigs with Dell, the cost is ridiculous. Like I
Yeah.
don't know where they get their prices from. It's like $1,000 for an extra 64 gigabytes.
Right.
So don't buy more than you need. Hop in your
How do you
task
find out?
manager.
Hey, how do you find out how much you need
Yeah,
with that?
load up your most extensive project. Load up your music player, your 20 tabs of Chrome. See how much RAM you're actually using in Task Manager. Just Control Shift Escape. It would be your Performance tab.
Hmm.
Um, and see how much RAM you're actually using. If you're at 20, let's say you have a 32 gigabyte system, your system shows 24 gigabytes of use, you think you're okay. Actually, you're probably getting a lot of things already sent to the hard
Mm.
drive.
Hmm.
I would say if you have 32 gigs of RAM and you have 24 gigs used, it's time for 64.
Hmm.
If you have 64 gigs of RAM and you're at 48 gigs of use, you're probably fine. I wouldn't worry about it. But if you're at 64 gigs of use and you see like 58 gigabytes
Hmm.
used, unfortunately, the next step up is 128.
Right.
You may only use, you know, 75 gigabytes, but that is just the increments it goes up.
So I guess as a little rule of thumb, if you're checking your resource monitor, you probably want to be less than like 75% of your total, give or take. Is kind
Yeah,
of the number you're thinking there, because then that's telling you that potentially you could spike above it, or you already have stuff being sent to the ROM, right? Is kind of.
right. So Windows will be more careless. Like it'll leave more things in RAM. If you have a ton of RAM, it'll leave more things in RAM than it really needs. But I'd rather have it in RAM than in the page file, which is, on your hard drive.
Hmm.
Um, I don't work on fun stuff. I just do a bunch of Chrome tabs for researching computer parts and Excel documents, and I could still break 12 gigs of
Right.
RAM use, and that's just really Chrome and ex tiny Excel files.
Hmm.
So people that are trying to, actually work with, Revit or whatever software, whether it's CAD or whatever,
Hmm.
I don't do anything less than 32 gigabytes, and I'm starting to really push people to 64
Yeah.
because the price difference isn't as drastic as it used to be.
Hmm.
32 gigabytes might be 130 bucks, and then 64 is like 250.
Right.
Um, but I mean that's at least like, and the components I'm getting, Dell may have a different formula for that.
When you're testing the machines or stress testing them, what would you say? What would you say are the programs that are using the most? Is it Revit with like big models? Is it I don't know if you're working with any point cloud type of models. I've heard that point clouds can be, if you're working with laser scans and point clouds, they can be some super RAM sucks.
Yeah, yeah,
Have you seen, like, is there a couple that really stick out of your mind? It's like that are just shooting up the RAM.
if it's a point cloud system, I maybe do like 5 laser scan builds a year,
Hmm.
but I basically tell people, doesn't matter what you're doing, just get the 128. You
And
might,
that's kind of why I brought it up, because it seems like anyone who's doing a point cloud is like, we need to just max out our RAM. That's it.
yeah, there's a lot of times you could get by with 64 gigabytes depending on what you're doing,
Hmm.
but don't do that to yourself because there might be, a software update, or you might have that one project and now you need the 128 and you don't have it, and you're gonna hate life.
Hmm.
So if it's like a point cloud machine, um, just get the 128 at that point. The people that need more than 128 probably know it,
Mm.
and that opens a whole new can of worms because now we're talking, your system's at least $10,000 now,
Right.
if you need more than 128 gigs of RAM, for various reasons. But yeah, that's kind of the RAM breakdown of it.
So what are the negative, what can, if you're running at that beyond that 75%, and you're potentially dumping, using ROM and whatnot, what are the sort of outcomes of that? Is that, are we talking about the potential of hard drive and storage
Um,
drive issues, or are we talking about like is it heat issue? Like what is, other than slow performance, like longevity wise,
yeah,
are we looking at damage potentially?
no, no damage, but the real issue is, crashing, blue screens. That's the biggest worry is
Mm-hmm.
that you're running out of RAM and now all of a sudden your system can't juggle everything and you actually crash your system,
Mm-hmm.
or your software just slows down to a crawl.
Mm-hmm.
And you'll be confused because you would have bought the good CPU, the good video card, the good storage drives, and you don't understand. And your files you're working on are on the system, they're not in the cloud. Um, uh, you don't know what's wrong, and it's probably you're running out of RAM.
Mm-hmm.
Um, you know, there's a process to check. You check, and oh shoot, yeah, I'm maxed out on RAM. So there's debates, or not debates, but I think there's an overhype on DDR5 at the moment.
Mm.
Um, Sometimes when you could pick, like for me, I could build a DDR4 system or a DDR5 system with an i9,
Mm-hmm.
13th gen. Um, the weird thing right now is that there's no 128 gigabyte DDR5 kits.
Got it.
So the other thing I tell people, if you're presented with the option of DDR4 or DDR5,
Mm-hmm.
don't stress it, get the DDR4 and save the money, unless
So
there's another
so
reason for that.
so for again for the lay folks, which I'll put myself in those because I just haven't geeked out enough on desktops in a long time. But the amount of RAM is one thing which we talked about, right? But then the speed of the RAM, and then also like you said, DDR5. For anyone who doesn't know, that's the classifications, and you may even be able to pick. Although I would imagine that if you're building a machine through a drop down, it's probably the same DDR, just different sizes, maybe different speeds. I don't know. It depends. But maybe just
Maybe,
explain to people like what does that mean? What does it mean? If you're looking at three different sticks of RAM, like what are the differences between these?
yeah, so Dell isn't probably going to give you as much options. This is probably more for the person that's trying to build their own system,
Mm-hmm.
or they're going with a boutique builder that is presenting them the option.
Mm-hmm.
You're going to see nowadays, you'll see DDR4 or DDR5. Um, and then you'll see your frequency or the mega transfers. Um, that'll be like the 4800 megahertz, the 5600 megahertz, the 3200.
Mm-hmm.
That's what that number will be. And then the next big number is latency,
Mm-hmm.
which is that CL number. Um, so your latency and your frequency or your transfer speed, those two numbers will determine the actual real world latency of the RAM. So, because
And,
I don't
and
have it
and for
memorized.
latency, you're essentially talking speed when it comes to computing, right?
Nanoseconds,
Yeah.
yeah.
Mm-hmm.
So, for example, so the actual formula, the real world formula, it's your CL latency. So, you divide that by your RAM speed, and then you multiply that by 2000, and you actually get your real world latency in nanoseconds. So DDR4, it's real easy to get 10 nanosecond RAM kits. It's very common. Whereas DDR5, you know, now we have more options, but you're probably in the 14 nanosecond range with a good kit.
Mm-hmm.
So what DDR5 offers you is massive improvement in bandwidth.
Mm-hmm.
So um, it's just the BIM applications don't really need that. The laser scan clients may, I haven't benchmarked. I don't do laser scans, so I can't say without a doubt that DDR5 is a requirement.
Mm-hmm.
But for Revit, DDR4 was actually benchmarking faster than DDR5
Mm-hmm.
when it first came out. Um, so whether you're getting DDR4, my recommendation would be 3200 megahertz or 3600 megahertz RAM. If you're getting DDR5, uh, do 5600 megahertz on a workstation. If you like to tinker, going over 6000 is a lot easier now with the Intel 13th gen platform, but you could potentially create that's an overclock. You're going to create issues potentially, and you're not going to feel a difference. So I'd say just get 5600 megahertz, um, and be happy. If you're doing 128 gigabytes, this is the big issue with AMD. If you're doing 128 gigabytes on AMD, it's gonna kick you down to 3600 megahertz on DDR5.
Hmm.
That's horrible. Um, I've tried everything I could to get it to boot faster than that, and it's just not worth it.
Hmm.
No one should have to do all that trouble. Whereas Intel, 4800 megahertz to 5200 megahertz, I've been noticing is possible, but that's it. That's it. It's we're not there yet. It's not going to be faster than that.
Got it.
So that's why I do a lot of DDR4 builds, because I could get a matched 128 gigabyte kit, 3600 megahertz, and it's going to run, and the latency is going to be great,
Mhm.
and it's going to save you money too.
Awesome. I'm sure everyone loves that. All right, so we're going to take a
Yeah.
quick break, and when we come back from the break, we are going to jump into graphics cards, I think. I think that'll be a good one. And then maybe we could touch on hard drive a little bit. And then I wanted to make sure that we talk about sort of how all this compares, or the knowledge and the thought process compares when we're talking about laptops as well. So we're kind of focused on desktops and components, but I also want to make sure that we don't forget just the sort of things to know when you're thinking the same idea, but on the laptop front. So with that, real quickly, we'll take a quick break to see our sponsors. So this season of BIM After Dark Live is sponsored by RevitFamily.biz. For those of you that don't know what RevitFamily.biz is, and that little ad didn't tell you, it's a family creation company by Brenton Weiberg, who is going to be on the show this season as well. He's been on the show plenty of times, and he makes specifically family libraries specific for residential applications. And so he's got cabinets, he's got doors, he's got windows. They're awesome bundles. I've used them. If you saw my Modern Kitchen series, I used them in that, and I've used other families throughout. And they're phenomenal families. Brenton's awesome. So not only did he sponsor this season of BIM After Dark Live, he also is offering you guys, if you look up here, 20% off any bundle, any package, anything you purchase on his website using the offer code RevitKid23. So head on over to RevitFamily.biz and check out what Brenton's got to offer, and support those who support us. All right, awesome. So, Anthony, let's jump back into it. So we talked about processors, we talked about RAM. I think it's probably time to talk about graphics cards, uh, and
Right.
and I think we'll have to control how long we talk about graphics cards. I'm sure it's something that we can go on for forever. But and
Yeah.
before we jump into it, and I think it kind of we can probably take the topic and transition into graphics cards from this same topic. I think someone did mention the chat, and it always comes up when we're talking about AEC programs and builds, is workstation setups. So I don't even know what it's called. It used to be Xeon. Is it still Xeon? I don't even know what the workstation Intels are called anymore. And then the Quadro cards and that whole thing used to be sort of the gamut. Maybe just a quick public service announcement on what should we even bother looking at workstation or whatever they're called now,
Oh,
workstation
oh.
setups for what we're doing, and have you tested and have you spent the time to say maybe this is a viable option, or is this not even worth the effort anymore?
Regarding the Intel Xeons,
Xeon, is it still called Xeon? I just want to make sure
yeah,
it's still
yeah, it still is.
Xeons, which means when you use Xeon, I believe you have to use like a Quadro OpenGL type of card, right? Something like that. Or
Intel Xeon can be paired with a GeForce card.
okay.
Um, I honestly think Intel might be dropping the Xeon for like the normal i7, i9 range.
Hmm.
I haven't seen one released for the current one, and
Okay.
I think there was an announcement they're not going to do it anymore. But I don't want to misspeak there. Uh, they did wise up. The last few Xeons had some hot rods in them,
Hmm.
but ultimately they still just weren't quite as fast as the K SKUs. Um, but yeah, typically you're wasting your money. People get the Xeon because now they could run the ECC RAM,
Hmm.
but unless you're running a server, you're not, if you're not hosting anything, really you just don't need it. So that was the only reason to get a Xeon. AMD actually can run ECC RAM if you're very paranoid about that, or if there's a certain
What
application you're trying to do.
what is ECC RAM?
So ECC is error correction code RAM, meaning it double checks and makes sure the data's correct, and it's just making sure that there's data integrity, um, and that there's no corruption. What's kind of cool, DDR5 kind of has on die ECC,
Mm,
meaning it's kind of doing that, but it's not a replacement for real ECC that's monitoring the flow of the RAM or
mm,
of the data. DDR5 can only do it once it's on the actual RAM, then it
mm.
could do that. So that's one cool thing that normal DDR5 can do, but otherwise, ECC really it's meant for
I
servers.
was just gonna say it's pretty much servers, yeah, and that's the only time
Yeah.
I've really heard it is in talk with servers. That's why I wanted to make sure clarify. Okay, no, so I just wanted to put that out there. Someone asked it, and I know it. I think to your point, I think I'm seeing less and less of those builds and marketing of the workstation, the Xeon type of stuff. So maybe it's a thing of the
Yeah.
past anyway. So we'll let's move on to graphics cards then. So, um, we talked about we talked about processors, we talked about RAM and limitations and so on and so forth. So then graphics card, obviously, I would imagine that just get the highest that you can afford, but to some extent, there's a lot of reasons why you may not. First is the price of, let's say, a
Right.
4090, the availability sometimes, right? And then, what else are we looking for? So there's, when it comes to a graphics card, to me, having not built a custom PC myself, a desktop, I should say, for a while now, there was a lot less options back when I was building them, and now you look at it, and not only do you have, the array of of actual series numbers, the 3080s, 3070s, TIs, etc. But now you also have different brands, right? You have PNY, Gigabyte, MSI, all making the actual 4090, so on, and then there's other options, within it. There's speeds and stuff. So like help us get better at choosing, managing our budget, but also choosing the card that's going to do what we need.
Yeah, so I don't want to disregard AMD's professional graphics,
Mm-hmm.
but I don't build with those unless someone needs it. And actually, I forget the name change, but the TFL channel actually exposed that there is a bug with AMD graphics, whether
Mm-hmm.
it's their pro graphics or their consumer graphics, where it's actually just running slower in Autodesk applications. So that's why I will not mention AMD just because it's
Mm-hmm.
an NVIDIA world. Unfortunately, it's all about NVIDIA. So don't get caught up in the hype about Intel having a Pro card or AMD's Pro cards are on sale or whatever. Just buy NVIDIA. And I hate to say that because they do some weird things.
Yeah.
And they denied my partnership because I put GeForce in workstation cards and workstations. But you just got to buy NVIDIA.
Yep. Got it.
And within NVIDIA, you have your Pro. They used to be Quadros, and now I don't know what the heck. They're the Pro cards, but
Mm-hmm.
you got Quadros and GeForce. GeForce are your gaming cards. Quadros, your workstation. That would be like an RTX A2000, A4000. Um, the naming is super bad now because now you had an RTX A6000. And now, oh, the RTX 6000 Ada is the new one. So it's very confusing for normal people that aren't, I think, in this world.
Mm-hmm.
But if there's an A in front or not an A, I guess actually, I don't know how to. NVIDIA needs to make up their
Yes.
mind with their naming. But you don't need a Quadro card for Revit. Lumion, Enscape, they're all based off of gaming engines.
Right.
So gaming cards are obviously fully capable of doing that.
Mm-hmm.
Unless you're working in SolidWorks, there's really no reason to go with a pro graphics card.
Mm-hmm.
Um, I'll retract that in a minute. Um, the main reason I sell workstation cards today are when you need more video RAM
Mm-hmm.
than what you get on a GeForce. So one of my clients, they do some crazy high-end renders, and they actually exceed the 24 gigabytes that you can get on a 3090 at the time. So their next system, we're going to be building it with a 6000 ADA, because that's 48 gigabytes of VRAM versus 24. So if that's not you, there's really no reason to go Quadro. Um, so now speaking within the RTX, the GeForce world, there's GTX and RTX video cards.
Hmm.
Um, and that's the RTX cards are capable of doing real-time ray tracing through a dedicated on-die, you know, processor, whereas GTX cards, they can still technically do real-time ray tracing. They're just not optimized for it, so it'd take longer. And by now, all of the GTX cards are so old, you shouldn't be using them really for visualization.
Hmm.
Um, there for Revit, really, you just need enough VRAM. Just about anything with enough VRAM can operate Revit. So at least 6 gigabytes is my recommendation.
Hmm.
Um, but in practice, I try to sell everyone on the RTX 3060 12 gigabyte version. It's more than enough than anyone would ever need, and it's like a $420 video card.
Hmm.
I don't even think you could get a A2000 for that much. I think the A2000 might be almost 500.
Hmm.
Um, so yeah, because the A4500 is about $1,200. So yeah, the A2000 is about 5 or 600. So for less than an A2000 in price, you're getting more performance.
Hmm.
Um,
So let's I guess if we think about that, and that's great. That's awesome. And I know when the 30 series came out, I was super impressed with the amount of VRAM they were giving us right off the bat,
well,
and
on
the
some
pricing.
cards,
Some cards.
yeah.
So like let's say maybe we put that as a baseline if you're a Revit user, and that's maybe all you're doing. But then let's say now you jump up and you're using Enscape, Twinmotion, Lumion. Is that the point where now you're like, well, now it makes sense to pay a little more for a little more VRAM, but also maybe what's the difference between the 30 and the 40 series, for example? If you're looking at a 3060 that has 12 gigs of video RAM versus a 40, I don't know which one has the 12 gigs anymore of the 40 series, but the 40 series that has 12 gigs,
That'd be the, yeah, 4070 Ti, yeah.
4070, there we go. Um,
So
what are you seeing there? Is that would that even be worth the jump for if you're a Revit user using Twinmotion, Lumion, etc.?
that's the beauty of the 3060 12 gig model, is that you could get your feet wet, with visualization software.
Mm-hmm.
Um, if you have to open a file every now and then or whatnot, it's extremely capable in that regard.
Mm-hmm.
But anyone that's like working in those softwares frequently should do themselves the favor and get a card that's more powerful. You're gonna render a lot quicker.
Mm-hmm.
With more VRAM, you could have more elements loaded. You know, you could just do so much more.
And
But
does that mean jumping to the next series or jumping to more VRAM in general? So if you went from a 3060 to a 3090, for example, as opposed to a 4070, is our what because the cost difference there could be pretty
right,
dramatic too. Are you going to see more benefits of jumping to the next series with the same VRAM or staying in the series
yeah.
and getting more VRAM?
This answer is gonna be very relative to today
Hmm.
because of the
Of
weird
course.
spot we're in. Traditionally,
It'll change tomorrow after we finish this video, right? That's just how fast these
yeah,
things are moving.
right. Because we're in a weird time where normally once NVIDIA launches their 4080 or 4090, the other cards come out so much quicker than what we're experiencing.
Hmm.
The 3060 and 3070 Ti, they're kind of lingering. I think they had an abundance of inventory and they just haven't gone out of stock yet, so we're not seeing their replacement yet.
Mm.
So that said, for today, if you find a 3080 or a 3090 in stock, I wouldn't waste your time with
Mm.
it. I literally go 3060 12 gigabyte, and if you need more than that, it's time to get the 4070 Ti.
Hmm.
That'll still get you 12 gigabytes of VRAM, but way more horsepower. Like it'll beat a 3090 horsepower.
Hmm.
And it's about a $900 video card. So if you still get a 30, I mean, the 3090 has the value of VRAM, but if you need 24 gigabytes of VRAM, the 4090 at $1,800, if you gotta realize you're making money off of your work.
Hmm.
Don't waste money on old hardware. If you want your video card to last you 3 or 4 years, why are you gonna buy it at the end of its life cycle already? Get what's out, you deserve it because you're working hard. I mean, I can't speak for everyone's financial situations, but the 3090 is still a good video card. It's just the 4070 Ti is better than it
Hmm.
from a horsepower perspective.
Hmm.
Um, the only reason the 3090 could do better than the 4070 Ti is if you need more than 12 gigs of VRAM,
Hmm.
then yeah, the 3090 would be better. But yeah, 3060 12 gig. If you need more power than that, go 4070 Ti. If you're in visualization software, you really got to accommodate to the amount of RAM you use.
Hmm.
Um,
So,
you
so
don't need a 4090 if you can just wait a little longer.
yeah.
But if you need that VRAM, you need the VRAM. There's nothing you could do about it.
And so,
And
so then I guess, because when you start looking at 4070, 4080, 4090 especially, that's when you start seeing the price. That the price difference between those three is pretty dramatic, right?
yeah,
It's like 900 I think for 4070, right? And it's like, I don't know, maybe 1200 or something for the 4080,
right.
and then 1800 to 2000 for the 4090. So and are is that specifically you're getting more VRAM, or you're also getting other is there any other features in that 4090, or is it just VRAM you're getting?
Essentially, well, each card does get more power, more performance,
Hmm.
but each step gives you more VRAM too.
Hmm.
So the 4070 Ti, way better from a performance aspect than the 3090 at this point. Generally, gets you 12 gigs. Then the 4080 will get you 16 gigs for that 12 to $1,300 range. And then the 4090 will get you 24 gigs for that 18 to 2000. But
Hmm.
then going back to the Quadros, the A4500 has 20 gigs of VRAM at about $1,200.
Hmm.
Um, that's essentially equivalent to a 3070 Ti in performance.
Got it.
It has 20 gigs of VRAM, but
Right.
you're paying $1,200 and you're getting something that has a $500 performance on GeForce.
Hmm.
Um, the A5500, which I think is like a $2,000 Quadro,
Hmm.
that does have 24 gigabytes of VRAM. I'm going off memory here. I think it's 24. That's going to be more on par with like a 3080 Ti. So that 4070 Ti has more performance than that A5500, and it's cheaper. It has less VRAM, but unless you need that VRAM,
Hmm.
there's just so much more value on GeForce.
So then let's talk about balance then. So you mentioned you mentioned balance, and so if I'm looking at and I'll use myself as an example, right? I've got a desktop down here that's 2.5 years old, I think. It's got an i9, a decent i9 in it. I don't remember exactly which one, but whatever was 2.5 years ago, as far as and it's probably the top of my line, top of the line, 2.5 years ago. It's got 64 gigs of RAM, etc. But it's an old graphics card, right? It's a 2070 Max Max Black, or I don't know, Super Max, I think, something like that, Super whatever, Super
Yeah,
Black.
super.
So it's, I think, 8 gigs of VRAM, but it's a 27. So it's old, right? That's a 2.5 year old
Yeah.
card. So thinking about balance, right? If I was to just say, all right, I'm going to buy a 4070 or something, and put it in there, think about the rest of the hardware. Is that out of balance because the processor's 2.5 years old, or the speed at that point in time of the processor, since it was a higher end, is okay working with the graphics card like that?
It's it depends what you're trying to accomplish at the end of the day. It's in a way it's acceptable to upgrade the video card,
Hmm.
but it's at the point where it's almost better just get a whole new workstation because you're gonna benefit so much from a newer CPU.
Right.
The 9900K, maybe 2 years old,
Hmm.
would have run the RFO benchmark in the 80-second range or so.
Hmm.
Um, the equivalent, even the i7, I'll just say i7,
Hmm.
it's gonna run it in the 50-second range, 55, 56-second range. Um, so
So that's
you
almost
bet,
doubling the speed of the RFO benchmark in 2 years with
yeah.
and that's the i7 versus an i9. And that's just simply because of the technology and the processing, the latency, and all the stuff we've talked about has changed.
But if you're building your own systems or you're upgrading an old one, you could upgrade your video card and then bring that new video card to your next system a year later or whatnot.
Mm-hmm.
So the tricky thing is with these new video cards like the 4070 Ti and higher, all these 4000 GeForce cards, they're not super power hungry, but they've introduced a new connector.
Mm-hmm.
So that's going to create some issues for older power supplies.
Mm-hmm.
Um, Essentially, you're going to need at least three PCIe 8-pin connectors to power these new ones
Mm-hmm.
with included adapters. Um, some of them might even need four, but the ones I've seen typically are just three.
Mm-hmm.
I guarantee you, like some Dells and Alienwares may not even have the connectors available to power a new video card.
Mm-hmm.
So that's why you enter this weird world of you have to do the research with the system you have. Um, I don't think a new video card would fit your BIM box.
Mm-hmm.
That Striker 2 chassis, it was a really cool chassis, but I don't even know if those
Yeah, I was
video
gonna say
cards would
the length
fit.
of it. It might not even hit. It might, where the radiator is on the bottom there for the CPU. I was yeah, and
Yeah,
I've never even measured that. But again, this is I think this is important for people to understand. It's kind of it's nice with especially with desktops. It's nice because you can swap out components and whatnot. But and I found this even when I was in high school building gaming PCs. At some point in time, it was time to rip out the motherboard and start from scratch because, like you
yeah,
said, and it's important that that balance of the system, putting a Ferrari engine in a in a Toyota Tacoma or something like that, right?
yeah,
That's
yeah,
it's gonna it's gonna make a lot of noise and spin the wheels real fast, but when I even get the wheels to the ground, right? It'll
yeah.
burn out and do God only knows what. So no, I think that's valuable. And then yeah, we didn't even get into power supplies and how that affects it. I don't think we necessarily need to today, but that
Man,
that is something to think about too.
yeah, I know, man. Time always goes so quickly. Can I touch on cooling a little bit?
Yes, I think we should. I think we should touch on cooling, and then I do want to just hit a little bit on just some high level laptop ideas for folks
Let's
just
do
to
the
take away from
laptops
that.
first, I
Okay,
guess.
okay.
All right, what do you want? What do you want to talk
I
about
think
at the
in general,
beginning?
we've been talking about desktops for pretty much this entire time. I think generally speaking, some of the ideas still apply to laptops, but maybe just if I'm doing the same thing for a laptop, I'm building a laptop, I'm picking it. If I'm custom, semi-custom, because I guess to some extent laptops are limited to customization to some, right? But
Right.
sort of like what should I think about when I'm looking at options for specs on the laptops that may be different than what we
Yeah.
just said for the last hour on desktops.
Yeah, I basically want to bring an awareness that laptop components are not equal to their desktop counterparts. They're named the same,
I was just gonna
but
say, even
they're
if they have the same name, is
right.
they're not this equal. Got it.
Yeah, and we've seen this historically. The chassis you have for your laptop will determine how much power the manufacturer is going to allow to go to your components.
Hmm.
So you really have to be a smart shopper. When you're buying a laptop, you have to realize what specs you're looking for. Today, let's go with like a 13900H i9 processor and an RTX 4070. These are laptops that are rolling out right now.
Mhm.
NVIDIA's defined the power range for a 4070 so drastically. It could, I believe, operate normally as low as 35 watts, I believe it is, and as much as 150 watts. So that allows manufacturers to put them in really thin laptops.
Mhm.
and beastly laptops, that that video card's going to operate completely different in the two machines. So the biggest tip I have is look and see what size power adapter comes with your laptop you're considering purchasing. That's kind of like the easiest way to look at it. If you're buying a computer that has top end specs and the power adapter's under 200 watts, you're essentially getting gypped. Unless having a razor thin laptop is more important than performance.
Right.
Um, there's videos that have been done on this with the 3000 series video cards and the 12th gen laptop models where some big name manufacturers are packing top tier parts and it's like a 160 watt power adapter
Mm.
when it should be like 280 watts. So,
So to that extent, then, because that's kind of, I'd say the range I've been seeing are 180, 230, 280 is probably the range. So you want to at least be above 200, and ideally, if you're looking at a 230 to 280, then you're probably getting more out of those components than if you're under
right.
it.
Yeah, look at the like so once you determine what parts you need, um whatever models you're shopping, look and see which one has the biggest power adapter because manufacturers are going to be cheap. They want to save. They're not going to give you a bigger power adapter than you need. So it's very intentional if they're giving you a 280 watt power adapter, they're not trying to be nice. It's intentional. Um so just keep in mind it's not equivalent to a desktop. Uh but within the world of laptops, get the bigger laptop, get the thicker laptop, get the one that has a bigger power adapter, um, and you'll also, not crash your system. Laser scan clients, there's someone I'm friendly with on LinkedIn, and he's always complaining about what they buy him. They expect them to do scans and process them in the field, and they do this thing overheats and blue screens all the time. So get the thicker laptop with better cooling. But everything basically applies outside of that.
Mhm.
The RAM requirements, um, your storage requirements, your CPU requirements. It's very similar on both, other than just know it's not
Mhm.
the same component as your desktop.
So I think we can transition into cooling by talking about maybe laptop cooling first, because I do think that's an interesting topic um, that that I think should just raise awareness of, which is like you just mentioned there, right? The specs of thin laptops that you see are extremely impressive, right? But like you just said, there's you're buying the specs, but may not actually be using the full extent of those specs.
Right.
And on that line too, I've noticed that the cooling of these thinner laptops, right, can be extremely challenging as well. I for one, our entire team who uses laptops suggest, and I suggest, basically require that they also use cooling pads with them as well. I think that does help a little
Yeah.
bit, but the other thing is making sure that, and I don't know if you've run into this at all, but making the fans can be loud on laptops too,
Oh yeah, for
and
sure.
on our laptops with what we're doing, they're pretty much on all the time, and they're on like 60% or more like all the time. And so I have seen many people turn down the settings and turn those fans off, maybe as a PSA, letting people know why they're loud and what that means.
Yeah. So when your laptop has different power modes, like, multimedia or maybe a gaming mode or
Mhm.
whatnot, it's not just adjusting the fan curves, it's adjusting the amount of power that the components are allowed to use. So, be sure to be in the highest performance mode your ears can tolerate. Um, Laptops more recently have started using more cutting edge thermal compounds. So I resell electronics. They've switched to a liquid metal thermal compound, and it looks metallic. It almost looks like mercury.
Hmm.
That actually allows them to be pretty quiet, but ultimately, once the cooling gets heat soaked, yeah, it's like fans are spinning just like anything else.
Mhm.
Some laptops have liquid coolers you could attach to them.
Hmm.
Asus has kind of pioneered this, and electronics has that feature. Um, so you could actually get all your performance in a much more quiet scenario.
Hmm.
Um, but yeah, the laptops, your cooling, there's no magic. Like a thin laptop is gonna suffer from cooling. They'll try to do cool technologies like vapor chambers,
Hmm.
but it's just a handicap. There's no magic. A thin laptop is not gonna cool as good as a thicker one.
Yeah.
Um, it's not like it's thicker because it's not as advanced. It's thicker because there's more cooling in it.
Right.
Um, so regarding laptops, that's kind of a rule of thumb.
So I have noticed, and I don't know if you've noticed or at least pay attention to that. I have noticed that simple cooling pads do tend to reduce the temperature of at least like what's showing up in the BIOS for like a CPU and a GPU by a
Yeah.
little bit, not a lot, but a little bit. And so I've definitely suggested that. Is that something that you
Oh,
suggest
yeah.
for sure if
So
you're
it
using
does
a
help
laptop all the
because
time?
yeah, it's not recirculating the hot air anymore. When you're
Yeah.
using a cooling pad, you're making sure it's being fed cool air.
Hmm.
When it's on your desk, it's really easy for just hot air to recirculate back
Keep
into
going
the
in. Yeah.
laptop.
Hmm.
Um, so cooling pads do work. It's not gonna it's not gonna solve all your problems. It's more like it'll make a good laptop better,
Hmm.
but a crappy cooling system is still not gonna be great. It'll be a little better, but it's, maybe what have you noticed? Maybe like a 5 degrees Celsius
Yeah, I think
difference.
five. I think on the CPU and 5 to 8ish on the GPU, give or take, is kind of what I noticed.
Yeah,
On the one I have now, which has it's nice. It's got a one bigger fan kind of thing, and it lifts it off. Not anything dramatic, but just noticeable.
yeah.
Which
And then uh can we touch on just the CPU cooling
yeah,
in
yeah,
desktops?
yeah, definitely.
So just as a without trying to do like a master class or anything, with your i7s, your i9s, really those CPUs should be liquid cooled. So if you're shopping a system that has an air cooler on those processors, just know it's not going to blow up on you, but that means it's going to strictly conform to the Intel factory spec. And that means theoretically it's not overheating according to Intel, but that means you're going to be at instead of 4.8, 5.2 gigahertz, you might be at 3.8, 4 gigahertz. So you're losing out on performance. A really good air cooler might be $80 and a really good all-in-one cooler might be $200. It makes no sense to buy a $700 processor and throw a $60 air cooler on it.
Hmm.
Um, so keep in mind when you're shopping a system, these new components are hot. The 13700K, today's i7 is a hot rodded i9 from last generation. They have the same core counts. They have basically everything the same, except it's a lot faster. They've cranked up the power allowance and they cranked up the frequency, and that comes at a cost of heat. So just keep in mind when shopping a workstation, all-in-one coolers, they're not going to leak on you. The most common failure is the motor stops working. It's an electrical failure.
Hmm.
Um, I haven't dealt with one leaking, I don't think ever. Custom loops, they're amazing, but you know, I had one leak. I pressure test every single system. I think it was a bad batch of fittings because two fittings started leaking. Thank God nothing got damaged. But it was a Samsung drive that failed. And so it got shipped here to just do maintenance and everything. And when it arrived, there was water on components. Pressure testing showed, oh shoot, it wasn't leaking when it was stationary at their desk, thankfully, because there was a 3090 Ti sitting right under where it would have leaked. But so leaks can happen.
But
Pressure.
the ones the out of the box systems, the out of the box cooling systems that are not custom built, those are pretty good as far as
Yeah, your most common failure is electrical, and usually custom loops. I've built many of them. They really, I think since 2015, I've probably built maybe 20 custom loops, and this was my first one ever leak. you pressure test before you ship
Mhm.
in order to make sure there's not a problem to begin with. But
So
anything,
that's a great tip. Is the especially i7 i9. If you're buying a system that's air cooled, then you shouldn't buy it. You should buy a liquid cooled system for that specific CPU.
yeah,
Yeah,
the i7 and 9 air cooled is like that thin laptop.
yeah.
It has the specs, but it's handicapped by the cooling.
So maybe just real quickly to finish it off, explain why that's important. Why is cooling important for processors, graphics cards, for pretty much all the components that exist inside there?
Yeah, so talking about all the components, your NVMe drives,
Hmm.
they are hot running now. So those actually need good heat sinks, especially most motherboards are placing them so close to the video card.
Mm-hmm.
Um, Last year I saw my first, NVMe drive thermal throttle because there was a 3090 right next to it, and all these video cards have passive mode, so there's no circulation.
Hmm.
We had to change the configuration on the fans. Uh, so actually pay attention to your NVMe drives, your SSDs now. Um, these components are getting really hot where it's changed the way we build things.
And those are just
Um,
heatsink. There's no active cooling on those, right?
right, but heat sinks are really all you need on them.
Yeah.
It does
But then you need the
wonders.
heat to go somewhere after it sinks away from it, right?
Yeah,
That's
traditionally I used to build systems where they're neutral pressure, so you have air drawn in and air escapes out the back.
Mhm.
But with these higher output video cards, they're basically ovens inside these components. I've switched to strictly pure positive pressure to help cool everything even better. But yeah, heat sinks alone on your NVMe drives are very welcome today.
Mhm.
Um, your CPU needs a good cooler just so you get the performance out of it. It will cut back its clock speeds to save its life. So it's not like it's gonna die on you.
Mhm.
When it's overheating, it's just, oh, I gotta go from 5 gigahertz to 4 gigahertz. Oh, still hot, 4 gigahertz to 3 gigahertz.
Mhm.
It's not gonna crash on you. You won't know this, other than slow performance.
Right.
You won't know this, and it won't blue screen until it's like 1 gigahertz and 100 degrees Celsius. So good cooling on your CPU gives you the performance you're paying for. RAM, you don't really need to worry about RAM as long as there's good air circulation. Motherboards, I don't know how Dell and HP motherboards can handle these. I mean, they must be putting, heat sinks on them now, but I always purchase motherboards that have adequate heat sinks on their power delivery circuits.
Mhm.
Back when I was building small form factor systems, that was extremely critical when you're overclocking. If the motherboard's not staying cool, it will affect your overclocks. That's a whole other subject we didn't even touch on, overclocking. But I knew time would fly, man. I'm sorry. I'm like,
No, this is
I,
great. This is great. No, I think in general, I think we hit everything that I wanted to hit. The idea is really, um, it's really to give the audience here some tools to understand what the hell it is that they're doing when they're buying these machines
yeah,
potentially every 2 years, right? Ideally, as frequent as possible, but definitely
yeah,
every 2 to 3 years. So for that, I appreciate it, man, and and I appreciate
yeah,
you coming on and taking the time. Is there where can people find you? Where's the best way they can reach out if they want to connect?
yeah. So I'm very active on Twitter, which would be Remis CS on Twitter. If you have any questions, DM me or contact me there. I'm trying to do good on LinkedIn, or my webpage, remiscs.com. Shoot me an email. Um, but yeah, I guess just in closing, if you pay more for a faster CPU, you'll benefit from those gains. But if you pay more for RAM you don't need, you're wasting money. If you pay more for a video card you don't need, you're wasting money. Um, don't buy a high-end CPU with bad cooling, you're wasting money. Like, um,
Awesome.
cooling and CPU are the two places you should probably spend a good amount. And then But it's all balance, man. I'm so bad at giving a definitive answer.
No, no, I love it.
It's balance.
The balance is a great one because that's not the way that I've thought about it over the years, and it is a good, it makes sense, and so I appreciate you coming on, giving the insight. I think everyone found it great. I mean, everyone in the chat found it great. Those of you watching this in the future, I'm sure you guys found it to be super insightful. So thanks a lot, man. I really appreciate it, and
Yeah, for sure.
I'll make sure to put all the links below to how everyone can reach you. And for those of you here with us live tonight, thank you for joining us tonight. For those of you watching in the future, thanks for watching in the future. Please subscribe to the channel here on YouTube. There's be another episode next week. And with that, I think I'll bid you all adieu. Have a great night, everyone, and talk soon. Awesome, man. That was good.